So in this video, I want to talk about the derivatives of inverse trig functions. And these are, again, another special case where we can't use any of our rules, product rule, chain rule, and all those. We have to just sort of memorize the formulas, and the derivation of these derivatives will be somewhere in our calculus course, but not here. So they're a little bit more complicated, and we need some more information and tools before we can actually derive those. But in this case, we're just going to memorize some of these derivatives. So let's say we have a function where f of x is equal to tangent inverse of x, and we want to take the derivative of this. Well, the derivative of this is there's a formula for it, and that formula is just 1 over 1 plus whatever is inside the tangent, which is in this case is x, squared. Now, there are other ones, right? And there is, like for example, if we have g of x is equal to sine of x, there's specific derivative formulas for this as well. And so I'm just gonna pull up a chart and look at the chart, discuss it a little bit, and this will be a pretty short video. So here it is. We have derivative of arc. Arc again is the same thing as inverse, right? You can write the negative thing right there, or you can say arc. So let's see, the arctan, which we just looked at right now, arctan of x, or z, it doesn't matter, is 1 over 1 plus z squared, or x squared. Arc sine of z, which again is the sine inverse of z, derivative of that is 1 over the square root of 1 minus z squared. And then there are certain places where these are restricted, right? Like for example, for arc sine, the derivative is not defined at -1 and 1. And you know, there is the reason for that is because it's going to be some sort of vertical slope, right? And that slope is undefined. And let's see. So yeah, so if you want to, a good way to memorize these is use the symmetry that they have. For example, sine and cosine, essentially the same formula, but the cosine is negative. Same thing with tan and cotangent, essentially the same formula, but one of them is negative, and very similar to secant and cosecant. All right, talk to you guys in the next video.